All right, this is going on page 46 when we're done. And we are moving into regression. Now, I told you a few weeks ago that, well, we found out about the test being hybrid online like in August. And then a few weeks into school, we found out you were going to have access to Desmos. And that day when we found out, we met, because the pre-cal teachers in the district, we meet basically once a week just to talk about some things. We had decided at that very moment that we were probably going to do a hybrid of, Desmos.com is where you need to be if you just got blocked out of everything. That it should allow you to. A hybrid of this and the Inspire, mainly because of regression. Because I know you've done regression on Desmos, but you have to know how to do like 8 regressions and the little subscripts and stuff. I don't know that we would all remember how to do them and get them typed in right. So then, a little while after that, they did an update on Desmos, which has some regressions now that you don't have to type it in, but not all of them. So we are basically trusting that the ones that are missing, I'm pretty sure that happened real quick because I think people freaked out. And I'm kind of surprised they haven't fixed it yet. I don't know why they wouldn't, but I'm not a programmer, so I don't know. But I'm quite sure it probably will be fixed. So we'll talk about those things as we go through here. I would imagine all of you used Desmos in Algebra 1. I would imagine most of you used it in geometry, probably just for trig because you needed a calculator and they didn't have class sets of calculators. If you were in pre-AP Algebra 2 last year, then you used it some. And I know you did exponential regression because that's what about made them lose their minds because they couldn't get the same answers and it was a hot mess. If you were in on-level Algebra 2, you probably didn't use it in Algebra 2, okay? And that's okay. I mean, because I'm going to teach this like you've never seen it before anyway. No matter how much you have used it, I guarantee you've used it more than I have because I've never taught with it because basically we had to use the Inspire, so there was really no reason. All right, so anyway, for our regression, these topics will utilize the graphing calculators heavily, and we often include context. In Unit 1, we'll be working with regression models. Mainly today, we're just looking at polynomials in linear, quadratic, cubic, and quartic. Cubic and quartic are what are missing in Desmos right now. We can do them, but not the easy way that they have now. But I'm trusting that they will probably be there eventually. If not, we can figure out how to put them in there. It'll be just fine. So we are going to use this table of data right here. And we're going to go put this into Desmos. So when you are here, you hit the plus sign and the table. And then you're going to type that stuff in. I just had it in my hand. Here we go. And if you see crazy things getting typed up there, I'll go fix them. It just doesn't. Oh, it's doing better now. Here's me saying bad things. No, it wants to work. I think I'm going to order a new keyboard tonight. I think it heard me say that too. Okay. Okay, so we've all put a table of data in Desmos before, right? Like this isn't new and surprising, right? Probably most of what we do today on it is not going to be new and surprising. That's okay, but just stick with me anyway. There's little things in here I want to talk about. I want to remind you that this is green, so the points are green. My data is green, like it tells you that. And I know you know that you can do all kinds of things with this, right? And I know part of what I'm going to show you is like a new thing. I don't know if this is new or not, but if you click this little magnifying glass, then it gives you a nice window for the data that you have. Okay, so just click that and it'll go whoop, and yours should probably look kind of like mine. That way you don't have to like do it yourself. So that basically, this is, I mean, when people hear that you get to use Desmos on the test, they're like, oh, well, it must be so easy now. And I just want to say, all right, you come take this test. I'll give you Desmos all day long. It does the same thing the Inspire does. It just, some of it's a lot easier to manipulate, especially when you got a computer in front of you. All right, so if you recall, back in the day, you had to then type in like y sub 1 with a little squiggly and do your thing to do regression, right? So here's what they've done. You see this little thing right here? Push that. Boom. And the default is linear, okay? Then when you click on this, there's quadratic, exponential, logarithmic, power, and logistic. It's like I'm a magician, right? So that looks like it's a pretty good fit, right? Well, look what happens when I click quadratic. Looks like it's a pretty good fit, right? What happens when I do exponential? You know, you can kind of click through them. Well, that one, not so bad, right? So when we're going to talk a little bit about how you find the best. We know this one is linear because this says the age in weeks and weight in kilograms of 5 randomly selected babies for a particular pediatrician's office are listed on the table above. So this is T and W of T. So this is my X, this is my Y. It says a linear regression, looking like this, can be used to model these data. So there are questions where you will be straight up told what to use, and then there will be questions where you have to figure out what would be the best. If you're told, your opinion about what is the best is completely irrelevant. You do what they say. Now, look at this line. I mean, you've been doing lines forever. Does it look maybe a little bit different than what you would expect it to be? Yes. If you're going to have that information, I would imagine you would probably expect y equals mx plus b. So there's a couple reasons I'm pointing this out. First of all, whatever they give you, that's what you use. Second of all, B here and B here, two completely different things, right? So if I don't put it in this form that they told me, and then they don't just say write the linear regression, they say give me the values for A and B. Like, you have to make sure you're pulling them from the right place, right? Plus the reasoning behind them liking this form, from what I understand, I haven't actually verified this, but I don't think these people are lying, is because in statistics, that's the form of the line you use for whatever reason. I'm sure there's a good reason. I have no idea what it is, but that's why they're using that to kind of in line with AP stats. So we're doing their thing, and it's fine. But it's still a line. It's not that big of a deal. Now, when you look over here, so it gives you all of this. We have the exact line. We have the R values, which we'll talk about later, and we have the residuals that we could plot, which we'll talk about that later too. Notice that this line, the decimals are to 3 decimal places. There will be some regressions that when we do this, it doesn't show you 3 decimal places. Then I'm going to have to show you what to do, because it don't matter what Desmos says. If you're supposed to have 3 decimal places, you need to have 3 decimal places. And it's not that complicated to get it. You just have to remember to get it, okay? So we're going to take this information, and we're going to write our linear regression model. Oh, I guess I'm not going to scroll. So from that, I don't start with the 0.185 because I need the y-intercept, basically, which is 3.545 plus 0.185x. Now what this is the model that will be the predicted weight of the baby. So it is a prediction. And to show that it is a prediction, instead of just having y equals, the proper notation is to put a little hat on it. Well, that looks weird. It's really just like the carrot top. My pen is stupid, just like an upside down V. And it has a fancy stats name. I don't know what it is, because it's y hat. I even went to the stats teacher last year, and I was like, what's the fancy name for y hat? She was like, I don't even remember. We just call it y hat. So, I mean, even if you're like a statistician, that's probably what you call it. But that tells you that that is the model for the data. It is a prediction. It's not like this is the equation. Does that make sense to you? And then because this is in y and x, this is actually in w and t. And this started with y equals, so this is perfectly fine. But if I was expected, maybe in a different question or on a multiple choice, that I needed to write it in function notation, then instead of y, we have wt, because that represents y, right? And then he just gets a big old hat on him. And then this would be 3.545 plus 0.185t, because it's in w and t. Right. Now, last year was a year of a whole lot of unknowns. This year, we have more unknowns than I expected to have this year, but So at this point, like this is the proper notation. And it was a great source of some discussion amongst, in some of the groups I'm in about whether we do that, whether that's the notation they expect, blah, blah, blah. And didn't get a great answer from people that knew what they were talking about. There's a lot of people that want to answer. But so I did this through all the regression stuff because I was like, I need to teach you properly. Then as we got more samples of things, more things, whatnot, I didn't see anything from actual College Board people that had the little hats on them. So I decided this year we're going to talk about it. I want you to see it. I want you to know it. And then we're not going to worry about the hats anymore. If it turns out they've decided, you know what, we need the official notation, we can put the hats back on and talk about it later, okay? But then you've also seen it. All right, so everybody good so far? Okay, so now we're going to use this. And I'm less worried about this type of thing now because you're in Desmos. But, well, let's talk about it first, and then I'll tell you what I'm less worried about. It says, using this model, what is the predicted, that should say weight, in kilograms of a baby that is 10 weeks old? All right, so is the 10 weeks, is that the input or the output? The input. So basically that's my x value. So basically I'm looking for a W of 10, or really W hat of 10 because it's a prediction. And it's going to give me some y value, right? So here's what I had to really stress when you had like a literal calculator in front of you. I am not taking 10 and just putting it in right there, right? Because maybe it would get me the right answer, but I have most likely rounded or truncated those answers, and you can't do that till the very end, so you use what's in the calculator. So that's what we're going to do. We're going to go over here, and then I'm going to have a new box. Sorry that I can't. Here, let me think if I put in a couple more new boxes, then you can see it better. I'm literally just going to type in x equals 10. 10. Come on. Ugh. Okay, there we go. 10. Yay. And then that's red. Therefore, the red line represents x equals 10. So then I can go over here. Since this is when x equals 10, I can click right there. If you click close enough to it, it knows you mean the intersection. You don't even have to tell it. So where like on the calculators, we were having to say intersection and go to the left and right, and I don't do all that anymore. And then if you push and hold, you can actually see that when x is 10, y is 5.395. And what are my units on this? Kilograms. Now, if that only had 2 decimal places, then it only has 2 decimal places. Does that make sense to you? It won't give you a million, but it'll give you probably at least 5 or 6, I think, if like there was more out there. And that was something else that I think was maybe a bit of an issue at the beginning, but I think Desmos was working on that too, so it doesn't really matter. All right, so the next one says the weight of the 6th baby is 5.3 kilograms. Using the model from part A, what is the age in weeks of the baby? So the information they gave us, is it the input or the output? The output. So something equals 5.3. I need the t value, so it's basically W of t that I don't know would equal 5.3, right? And I need to figure out what t is. Since this is the output, that's the y value, right? So I'm going to go back over here in this next little box. I'm going to type in y equals 5.3. Ay, not 3. Okay. It was working fine. 5.3. Okay. Not point. Oh my gosh. I'm going to find a better way to do this, because if I do this, I'm going to lose my mind. Okay. There we go. So now it puts in the purple line. Whoop. Now, where the purple and the red intersect, I really don't care about that, right? That's not interesting to me. For some reason, my point popped up. I don't think that happened to me in the last 2 classes, but I could be wrong. So when I click over here, and I can just tap right there, it gives me the point. And these are close together, but I click on this one, and see here it gives me 5 decimal places, which tells me there's probably more out there. But when I need this 9.486 to be my x value for 5.3 to be my y value, so remember you have to be correct to 3 decimal places. My suggestion is always that we write down 4 so that we don't have to worry about rounding and stuff like that. So 9.4864. And what are the units on here? Weeks. Very good. Any questions at all? All right, so most of what we did so far is probably not any different than some stuff you've already done, except that there's kind of different ways to do it now, and a little nicer ways. So let's flip this over. Let's talk about selecting an appropriate model type. So some problems will indicate which model should be used, just like that one. It'll tell you, this is what you use. And I will tell you that one of your FRQs starts off by telling you, you have some data and it tells you, use this model. And whether that's going to be a log or an exponential or a quadratic, nobody knows. We know what the other types of things they're going to ask, but you basically have to be able to do it with all the different kinds of regression, but it will tell you which one. But then there are also questions, well, you will also be expected to select an appropriate model type. Okay? And here's basically how we can do that. For linear models, we have roughly constant rates of change. Up until now, it was linear if it had exactly constant rates of change. But that was very clean, made-up data. With real data, that's probably not going to happen, right? But roughly, for the most part, that's what's happening. Quadratic models, roughly linear rates of change, those two things, not new news, we've been doing that, or roughly symmetric with a single maximum or minimum, meaning that you see your data, the y values, they increase, and then they decrease. That's most likely going to be a quadratic model. But of course, if you have data where the y values increase and then they decrease, could be quadratic, or if it starts to increase again, then it could be cubic or something else. But or involving area, because units are squared with area. That should make sense. Cubic models, basically anything with volume. So I want to show you, let's go back to this. And linear, we knew to use that because they told us to. But when you look at that data and then I make it quadratic, does that look like a pretty good fit too? But in the context of the question, does that really make sense? No, we're talking about age and the weight of the baby. We hope that, weight is increasing. We hope the baby doesn't get to whatever this is and then the weight starts to tank. That would not be good, right? That is not what is expected of, the great majority of babies. We expect it to keep increasing. And so that's why, even though they both kind of look good, context makes a difference here for sure, whether or not you're told. All right, so for each one, we are going to determine whether it would be a linear, quadratic, or cubic. Okay, so balloons are filled with water in preparation for an epic water balloon battle. Each water balloon is roughly spherical, because balloons aren't exactly spheres, but basically for some of them that we can use for things. So then it says the radius of each water balloon is measured relative to the amount of water it holds. Okay, so the radius measured for the amount of water. What type of measurement would we use to figure out how much water is in the balloon? It would be volume. Now, you could say, the last big storm and it flooded and I had 3 feet of water in my house. That's a lot of water. That's really all you need to know, is that that's a lot of water. But that's not like exactly how much water, because you would have to talk about volume. It'd be different in different rooms, right? So even though you can talk about water that way, that's not really what anything is talking about. So this would be volume, so we would say cubic, and then basically because it involves volume. Okay. Then Totino's pizzas are on sale at a local grocery store. The price of one pizza varies between $1.99 to $2.19, depending on the variety. Total number of Totino's pizzas are counted relative to the total price of the purchase. So would it make more sense if that would be linear, quadratic, or cubic? Linear, okay? Because basically just the price depends on the variety. That's all it is. So linear, price depends on variety. Alrighty, then we have a sprinkler. It's placed in a yard to water the grass. The sprinkler rotates in a circular pattern, so you got the sprinkler, and it's spewing out this water here, right? Basically to water that area. The radius of the circular path is measured relative to the area that watered by the sprinkler. So what do we think here? Quadratic, because it's area, yeah. So that's basically with words, but we're also going to look at how to decide with tables of data as well. Are we all good on that so far? Okay, so we're on to our next question. So before we do anything, we're going to put, I'm hitting the wrong thing, that's why. We are going to, you can just go in here and X out everything. And we're going to start from new and put in a table of data. And so put that data in. It'll take me a little longer because my keyboard doesn't like me. But actually, I think I'm just getting, instead of a keyboard, I don't need letters. I need, oh crap. I can just get a little keypad. 3.4. All right. So once you type in your data, you should also always take a second, double check what you typed in and what you were supposed to type in, and make sure they're the same thing. Because if not, it could cause you lots of problems. 18. Goodness gracious. 16.5 and 10.2 and 2.8. Okay. Whew. That was rough. All right, so now let's look at the data. Probably should have you look at the data first. If we look at this, okay, and I realize that I just had you type it in and you're probably looking at it, okay, and that's fine. But this may be a question that you don't actually get to use the calculator on, right? It may just only be the part A, and you don't get to type that stuff in, so we got to know how to look at it. So when I look at my output values, my y values, I start at 5, it increases, and then it decreases. So since my y values increase and then decrease, it makes the most sense that it is quadratic, okay? Now, would you say that the maximum value is 18? No, we don't know that for sure, right? But we do know that the maximum value occurs right around in here somewhere, right? It could be between these. So basically, your maximum value is somewhere between 17.1 and 16.5 is somewhere in there. Or maybe kind of close to 18, but it does not guarantee it. So don't fall into that trap. And it says to explain your answer using the characteristics in the data. So we would say quadratic, not because we just typed it into Desmos, but quadratic because the y values increase and then decrease. And I'm going to throw another and in there, which is not grammatically correct, so just don't tell your English teacher. But not only that, but like we start off at 5, and we go up to, we don't know that that's 18, somewhere up here, and then we come back down to 2.8. So not only do we go up and then come down, but and are roughly symmetric. Okay, that's something else that kind of helps you put that into perspective there. All right, so now I want you to go back over here because we're not going to have time to do anything else with this today, but I'm almost positive you would not be allowed to do this on the actual test to go back and forth to questions, but If we're working on something in class or you're doing an assignment and you don't want to have to type this, I definitely don't want to have to type this again in tomorrow. If your name is not up here, then it should say like sign in. Can I look over your shoulder? Okay, so go to log in. So click on log in, continue with Google, use your district stuff. Once you get logged in, then, because I don't even know if y'all knew this was a possibility, click on save. You can name this whatever you want. Okay, you can name it number, what is it, whatever number it is. And then tomorrow when we come back to finish this, you don't have to retype all that mess in. That's one reason why I wanted you to get typed in before the bell rang. We can just open it back up. Now it would be nice on the test if you could save it because you're not done with number 3 and you want to go back. And who knows, maybe that'd be an option. Maybe not, I don't know. But I don't even know if we'll know before the test. I guess you might find out on the test. But because you can do that on the calculator. Like you can save it and go back and forth. We'll see. But we'll finish this up tomorrow.